We are going to graph circles in lesson 9.3. You can see the standard equation of a circle over on the right of the screen, and this is the form for the equation when the center of the circle is at the origin. So if we were to shift the circle around at all, the equation would change a bit based on the vertical or horizontal shift, but this is the standard equation that we're going to use. And R in this equation is stands for the radius. So the measurement of the radius. Okay, so that's going to be taking our x coordinate and squaring it. If we add to that our y coordinate and square it, then we will get the radius squared. So we can use this to graph the various circles that are stated over here in these equations. Number one, we've got x squared plus y squared equals 9. So since we have it in the form, the standard form of the equation for a circle, x squared plus y squared is really equaling 9, which is r squared. All right, so this is the fill in for r squared right here. That's the value of it. So if I take my r squared, set it equal to 9, and then solve for r, I'm going to get plus or minus 3. We know that we're not going to be interested in the negative 3 because that we're going to throw that out. That cannot be a length of a radius, a negative measurement. So we're going to keep just the 3. And then from the center of the circle, which is the origin in this case, we're going to come out 3 units on all 4 sides. And then we'll do our best to connect those in a smooth circular line. All right, moving over to number 2, now we have x squared plus y squared equals 20. So r squared has a value of 20. All right, so we'll find the square root of both sides. Again, it would technically be plus or minus the square root of 20. We're going to throw out the negative solution and just keep the positive square root of 20. The square root of 20 is going to be difficult to graph, so we will plug that into the calculator, and when we do that, we will see that it is approximately 4.5. So I'll come up from the origin, this is my center, and I'm going to come up 4.5 units on the top, over to the right, the left, and then get the bottom of the circle as well. All right, and then connect as smoothly as we can. So now let's take a look at number 5, because number 5 is not actually in standard form yet. If you look up at the equation, we need our x squared and our y squared coefficients to be 1 in order for it to be in standard form. So this one has a 5 as a lead coefficient on each of those x and y terms. So the very first thing we need to do is factor the 5 out. So that's the GCF, the 5 on the left-hand side. So I'm going to factor that GCF out. And then to get the x squared plus y squared by itself, I'm going to divide by 5 on both sides. And now I have it in standard form. So if it's not already in standard form, you've got to put it in standard form before you can start graphing. All right, and then from here now we can see that our r squared has a value of 16, and then obviously from there then our r is we're going to take the positive 4, and the center of our circle is 0, and so we'll go to 4 on each of those measurements, and then draw our circle in. So it's pretty straightforward. The only thing you need to check for is that you have your equation in standard form before you start graphing. So now moving down to the next set of problems, they want us to write the standard form of the equation of the circle with the given radius, and we're assuming the center, or we know the center is the origin. So because the center is the origin, then we can use the standard form x squared plus y squared equals r squared. and they have given us the radius. So they've given us r here. In order to figure out what goes in for r squared, we just need to set the square root of 7 squared. So I'm going to take the square root of 7 and I'm going to square it, which hopefully you remember from our exponents chapter that in our radicals, the square is going to cancel out the square root. They are inverses of each other, so we're just going to end up with 7. And so this is our standard form of our equation for that circle. If we were to graph it, we would go to the center of 0, 0, and go up 7, down 7, to the right 7, to the left 7, and then connect our circle. All right, number 8 works the same way. It's just that we have a little bit more complicated of a radical here. But this is the radius. Okay, they told us that here. They gave us the radius, so we need to know the radius squared to write our equation. Okay, and so left side stays the same. I'm going to square the whole number of 2 to get 4. And then when I square the square root of 5, again, those are inverses, so they're going to cancel each other out. So I'll end up with 5 there. So my final simplified equation in standard form will look like that. So on the back, they are asking us once again to write the standard form of the equation of the circle, but now they're giving us a point, one of the points that the circle passes through. So one of the points on that circle is 2, 3. Our origin is still the center, so that means we can still use our standard form equation like this. It's just now we don't have the radius. We've just been given different information than we were on the previous problem. I have an x and I have a y. So if I square both of those and add them together, then I can get my radius squared, which is 13. Okay, and now I have my radius squared. Now we're not done because we just used x and y to solve for the missing piece of information we needed in order to write our standard form equation. All right, so the final form, you've got to go back, just like we've had to do in lots of previous function problems, where you solve for the missing variable and then you take that and put it back into the standard form of the equation. You leave x and y open, just like we always have, so that you can use a table to graph it if you would need to. All right, so we can do the same thing with number 11. We have our x and we have a y. Our origin is our center, so we can square our x, add it to the square of our y. All right, so 34 is our r squared. Take that value and put it back into the standard form equation. And there's the standard form equation of this particular circle. And in this last set of problems that we're going to do, they give us equations of both circles and parabolas, and they want us to graph them. So we need to just point out how we're going to tell the difference between the equation of a circle and the equation of a parabola that we did in the previous lessons. Number 13, if you look at that, it has an x squared term, but the y is not squared. So this can't be a circle. The y squared term, the y term also has to be squared in order for this to be an equation of a circle. So this is going to be a parabola. This one in 14, we have an x squared and we have a y squared. So that means this one is going to be a circle. So if we go back over here to number 13, we have to think about what we had to do, the steps we had to follow in order to graph a parabola. And the first one was to make sure that we have solved for the squared term. So in this case, I've got to solve for my x squared. So when I do that, I end up with x squared equals a negative 3y. Now I need to think about what it means to have an x squared term. So if the x is squared, this is the quadratic formula. This is the quadratic version of our parabola. This is a function. So this one is either going to open up or down. All right, so we have narrowed it down to that. Then we need to take the standard form for this type of parabola, which is x squared equals 4p y. Okay, so now I know that my 4p has to be equal to negative 3. So if I set 4p equal to negative 3 and then solve for p, I get a p of negative 3/4. My p is less than 0. So p is less than 0, so that's how I know that it's going to be a downward pointing parabola. Okay, my vertex is going to be at 0, 0 because this is the standard form of this equation. If you forget that, that's okay, because look, I can just make a table. I can plug 0 in for my x, and when I do that, I'll get 0 for y. So that's easy to solve for if you forget that the vertex is going to be at 0, 0. Then I'm going to look for a value for, and I'm going back to this equation right here because it'll be easier to solve for it there. I'm going to look for a value that I can plug in for y that will give me something that I can take a perfect square root of, because I'm going to end up needing to solve for x, which means I have to take the square root of it. So if I plug in for y negative 3, and make sure you put it on the correct side of the table then, this is my y value, I'm going to get 9 here. Well, the square root of 9 is 3, so I can solve for my x, and I can just use do that very quickly in my head and not need to pull out a calculator for that. All right, so there's my point. 3, negative 3 will put me right here. And so this is a parabola. This is my axis of symmetry right here. And so I'm going to just mirror this over to get my third point over here on the other side. All right, and then when I graph that in, it'll look like this right here. Now remember that the p value gives you your focus, which is on the inside of the, now they didn't ask us to do all this, but just to review this from our previous lesson, the p value of negative 3/4 would be right in here on the inside, and then the equal distance on the outside of the parabola would give us our directrix. Okay, so moving on to number 14 then. Now we know we have a circle. So if we have a circle, we know we need to check and make sure, of course, that it's in standard form like we have to do for every function before we graph it. This one is not, because the lead coefficient is 2 on both my x squared and y squared instead of 1. So I'm going to factor out the GCF of 2 on that left-hand side. I'm going to divide through by the 2, and I'll get x squared plus y squared equals 4. So my r squared is 4, and since my r squared is 4, it means my r is 2. So I'll go from the center out 2 units on every side, and then connect my dots. Okay, so pretty straightforward. Only things really to just remember and keep at the front of your mind as you're doing these is if both x is squared and the y term is squared, then you've got a circle. If the x is squared or the y is squared and only one of them, then you have a parabola. All right, and then always remember, make sure you are in standard form before before you try to graph it. All right, don't try to do anything before you make sure that the correct variable you need is solved for.